Continuing the problems on joint probability, let us solve one more example. Find the marginal distribution f of x and g of y for the following table. Also find the covariance expectation of x, that is mean of x, mean of y, expectation xy, the correlation, and also verify x and y are independent, and find p of x plus y greater than 0, the value of p of x plus y greater than 0. The table has been given where x takes the values 1, 2 and y takes the values -2, -1, 4, 5. Before we proceed with the marginal distribution table, as discussed earlier, we need to find the row sum and the column sum. So, considering the first row, f of x1, that is f of x1, this is f of x1 will be equal to 0.6 and f of x2 will be equal to 0.4. The sum together should be equal to 1. Similarly, the column sum, this is g of y1 if we want to consider, g of y2 is also 0.3, g of y3 is 0.1 and g of y4 is also 0.3. So adding them together, that adds up to 1. Considering the x and f of x values, the marginal distribution of x will be 1, 2, 0.6, 0.4. Similarly for y, -2, -1, 4, 5 and g of y is 0.3, 0.3, 0.1, 0.3. Now the covariance is given by e of xy minus mu x mu y, or the expectation e of x or mu x is given by x f of x. So 1 into 0.6 plus 2 into 0.4 is equal to 1.4. Mu y into gy, that is -2 into 0.3 minus 1 into 0.3 plus 4 into 0.1 plus 5 into 0.3 is equal to 1. Expectation of e of xy is equal to xy h of x comma y. That is, for this we need to consider the joint probability distribution, that gives to 1 into -2 into 0.1 plus 1 into -1 into 0.2 plus 1 into 4 into 0 plus 1 into 5 into 0.3 plus 2 into -2 into 0.2 plus 2 into -1 into 0.1 plus 2 into 4 into 0.1 plus 2 into 5 into 0, that adds up to 0.9. So covariance is given by e of xy minus mu x mu y, that's equal to 0.9 minus mu of x is 1.5 and mu of y is 1, that's equal to minus 0.5. Now for the correlation is given by covariance xy upon sigma x sigma y. So sigma square x is given by variance x is equal to e of x square minus mu square of x, that's equal to e of x square is 1 into 0.6 plus 2 square, that will be 4 into 0.4, that's equal to 2.2. So sigma x will be equal to 2.2 minus 1.4 whole square, that's equal to 0.24, and this sigma x is 0.49. Similarly, we get sigma y as 3.1. Therefore, the correlation is minus 0.5 divided by 0.49 into 3.1, that's equal to minus 0.329. That is, the correlation is in the negative direction. Now to prove x and y are not independent, if I show one value such that p of xy is not equal to p of x, p of y, then I can show that x and y are not independent, that is x and y are dependent. Now for p of x is equal to 1 and y is equal to -2, I have the value as 0.1. But from the marginal distribution, p of x is equal to 1 is 0.6 and p of y is equal to -2 is 0.3. And the product of these two will be equal to 0.18. So we can say that p of xy is not equal to p of x, p of y. That is 0.1 is not equal to 0.18. Thus x and y are not independent, they are dependent. For the next condition, p of x plus y greater than 0, I have to choose the values of x and y such that the sum should be greater than 0 and their corresponding values. That is, x takes the value 1, 2 and y takes the value -2, -1, 4, 5. Now, from the table I can say I11 is 0.1, that is I11 is this point, I12 is this, I13 is this, I14 is this, and I21, I22, I23, I24. From these values, if I take x as 1 and y is equal to minus 2, then x plus y will be equal to minus 1, which is not greater than 0. Similarly, if I take x is equal to 1 and y is equal to minus 1, I get the sum is equal to 0. Again, the condition is not satisfied. Similarly, when I take x is equal to 2 and y is equal to minus 2 also, the sum is equal to 0, which is not greater than 0. So other than these values of x and y, all other values can be considered because the sum will be positive. That is, when x is 1, y is 4. When x is 1, y is 5. When x is 2, y is minus 1. When x is 2, y is 4. When x is 2, y is 5. That is, x2, y2 means x is 2, y is minus 1. That will be equal to 0.1. And x1, y3, that is x is 1, y is 4, I get the value as 0. When x is 1, y is 5, I get the value as 0.3. When x is 2, y is 4, I get the value as 0.1. And when x is 2 and y is 5 is the value is 0.5. Adding all these values, the answer comes to 0.5.